What's up, guys? Lesson 77 is law of cosines. In 71, it talks about the law of sines. So I know some of you are confused by that. So we're going to go over that real quick just to review, and then we're going to talk about the law of cosines. Here we go.
Flack math! Give me some math and I'll give you some flack. Flack math!
So, law of sines. I have a triangle here, and I'm going to label it ABC. Okay, so these are the vertices of the triangle. Now I'm going to also label the sides. So the sides opposite those vertices, we're just going to do the lowercase version of those. It's very important that you label it this way. Okay, so now when we talk about lowercase b, we're talking about the side opposite of angle B. All the angles will be capitalized and all the sides will be lowercased. Yeah, that works. So to find the area of this triangle, we would need the height. Okay, so if we drew a little line here and call it H, then if we knew that height, then we'd be able to find this. So let's first of all go back to what is sine of A. Sine of A is opposite over hypotenuse, so H is opposite of A over C. Okay, so that's what the sine of A is. So if I wanted to figure out what H is, I would just multiply both sides by C. So H equals C times the sine of A. All right, so now technically we have our height. So our height is this. So how do you find the area of the triangle? Area equals base times height. Well, our height is C times the sine of A divided by 2. So 1/2 base times height. And since this is all multiplied, we're just going to write it without parentheses. So area equals 1/2 BC sine of A. Okay? So you could do the same formula with all these different letters. So area also equals, so this could be 1/2 AC times the sine of B. And this could also be area equals 1/2 AB times the sine of C. I'm just going to set all these equal to each other. So 1/2 BC sine of A equals 1/2 AC sine of B equals 1/2 AB sine of C. So if I multiply everything by 2, I can get rid of those 1/2. So BC sine of A equals AC sine of B equals AB sine of C. So this equation can all be written like this, and this is where we get the law of sines. Sine of A over A equals sine of B over B equals sine of C over C. Now this is a little bit easier to remember than all this stuff right here, okay? So sine of the capital A, or sine of angle A, divided by its opposite side, lowercase a, equals sine of B over B, sine of C over C. So this is the law of sines. So you can use this to find missing components of a triangle, okay? And that's what you did in lesson 71. So you can practice those by just applying the law of sines. Let's do one and then we'll come back to this. So in example 2 on lesson 71, we did this. So here's a triangle. Okay, and this is 48 degrees. This is 35 degrees. Okay, and this is our triangle. So A, B, C. And this is what we're given. We're just given this little 4 here. So now you know it's not a right triangle, so you can't use your basic trigonometric functions, trigonometric functions, okay? You can't use those functions, but you can use your new friend, the law of sines. Let's just write it out. So sine of A over A. So sine of A over A, well, opposite of A is 4, equals sine of B over, well, we don't have that, so we're just going to leave it B. So you're going to try to find B. That's your goal. All right, so sine of A, well, we know what sine of A is. It's sine of 48 degrees. So 48 degrees over 4 equals sine of 35 degrees over B. Okay? So let's try to get B by itself. And then we can just do one swoop of a calculator. I don't know. Swoop of a calculator and it'll get there. Okay? So if we get B by itself, we're going to multiply both sides by B and multiply both sides by 4 at the same time. So here's what we get. We get B sine of 48 degrees equals 4 sine of 35 degrees. Really, the cross product. So if you multiply these together, remember the fish method? Okay, so these are cross products. So multiply those together for your new equation. Okay, solve for B by dividing by sine of 48. So we get 4 times sine of 35 all over sine of 48. Well, we can do that. No problem. Let's go to our graphing calculator or your standard calculator. So if you're using this calculator, you can go to the GeoGebra. So we're going to leave that page. Instead of the graphing calculator, we're going to go to our scientific calculator. All right, so let's just type in our equation. So here's what our equation says. B equals, so we're going to solve for B. We're going to multiply 4 times sine of 35. Okay, and then we're going to divide it by sine of 48. Boom. So there's our answer, 3.087292900. Okay, so we're going to round to the nearest tenth. All right, so our answer is approximately 3.1-ish. So our answer is approximately 3.1-ish. Okay, so that is nice because we were able to find this missing side with just a couple angles on us, and it wasn't even a right triangle. So our basic trigonometric functions couldn't work, but with the law of sines, we can do that. So now in lesson 77, we're going to talk about the law of cosines. Okay, I'm going to just draw another triangle, and we'll label it here. So we'll call this A, this B, and this C. Remember, our lowercase a goes across from capital A, and our lowercase b goes across from capital B, and our lowercase c goes across from capital C. And then we'll just draw a height here. Boom, 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 boom. Call it H. And then we're gonna do something else here. We're gonna call this X. So if this is X, then this guy is gonna be whatever C is minus X. So this is C minus X. All right, now this is all to explain what the law of cosines is. Just like we did that big explanation of law of sines, you technically don't need to know how we derive the formula as long as you can use the formula, all right? But it's easier to remember if you can derive it, and it kind of locks in your brain and shapes you into who you are. It's special. It's one of those warm, tingly math moments. So we're going to try to explain this, but again, if you don't get it, how we explain it, as long as you remember the actual law of cosines, you're okay. So drawing this H divides this triangle into two right triangles, okay? So basically I could say like b squared equals x squared plus h squared, and also a squared equals c minus x squared plus h squared. I could say cosine of A equals adjacent over hypotenuse. So here's A, so adjacent is x over B. Or in other words, if I just wanted to solve for x, I could just say x equals, multiply both sides by B, B times the cosine of A. So far, so good? Okay, so let's simplify this guy a little bit. A squared equals, if I FOIL this out, remember I can FOIL it out, or I can do the shortcut, which is this guy squared minus twice that product, so minus 2cx, and that guy squared, so x squared plus h squared. So, and you remember x squared plus h squared is just b squared. So I'm going to rewrite this. A squared equals c squared minus 2cx plus b squared. Okay, so now I'm going to substitute this guy in right there for x. Okay, so a squared equals c squared minus 2cb cosine of A plus B squared. So we're going to just clean this up a little bit and kind of make it look like the Pythagorean theorem with a little touch on the end. So A squared equals B squared. I'm just going to rearrange this. Put the B squared first because it's alphabetical. Plus C squared minus 2bc cosine of A. Okay? So that looks a little complicated. This is how we derive it, but again, you don't need to know how we derive it. You just need to know that this is the law of cosines. Okay, right here. So you notice that basically this A corresponds with this angle A, and this B and C correspond with this guy here. So we can write it like that. We can also write it like this. So our law of cosines is going to be, can also be this. So B squared equals A squared plus C squared minus 2AC cosine of B. And then our third one, C squared equals A squared plus B squared minus 2AB cosine of C. Okay, so these guys are all the law of cosines. Okay, so that's what we can use to solve for missing components. So let's try example 1. All right, so I have my law of cosines over there. So we're going to try example 1. Solve triangle RST. So when it just says solve a triangle, so that just means find all the missing components. So let's draw a triangle here. Okay, call this RST. So this is 13. So lowercase t, remember it's across from uppercase t. So lowercase t would be 13. Lowercase r would be 17. And then we don't know this, so we're going to do lowercase s. Okay? So we're just going to just use one of these. So a squared plus b squared, or a squared equals b squared plus c squared minus 2bc cosine of a. So in this case, we're going to say that a is s. So we're going to say s squared. So lowercase s squared equals b squared, so 13. Well, we could write it like this if it's easier. So r squared plus t squared minus 2rt times the cosine of s. Okay, well, s they give us is 75 degrees. Okay, so let's fill in the blanks here. So s, we still don't know. S squared equals r squared is 17 squared plus t squared, which is 13 squared, minus 2rt, so r is 17, t is 13, times the cosine of s, which is 75 degrees. All right, so let's simplify this. S squared is approximately 343.6, and then when you square root it, S is approximately 18.5. All right, so now we have S, but we still have to find angles R and T. Now, normally, if you have two angles, you can find the third, so we just need one of them. So let's find angle R. So we're going to use the law of sines to find our missing angle. So sine of R over lowercase r equals the sine of S over lowercase s. Okay, so let's fill in the blanks here. Sine of R we don't know, but we do know lowercase r, which is 17. Sine of S, well, we know what S is, 75 degrees, over lowercase s, which we do know now, which is 18.5. So if I do a little cross multiplication here, I can say sine of r all multiplied by 18.5 equals 17 times sine of 75. All right? So then we're going to try to solve for r, right? So we're going to say sine of r equals 17 sine of 75 all over 18.5-ish. Okay, now how do you solve for r? Well, that's when we do our inverse sine function. So I'm going to change colors here. So we're going to apply inverse sine to both sides. So when you do that here, that cancels the sine function. Okay, so we're going to solve for this. So we're going to type that into our scientific calculator. I'm just going to use my normal Mac calculator here. So I'm going to say inverse sine. So the way I have to do it is I have to multiply all this together. So first I'm going to find the sine of 75 degrees. So 75 sine, and I'm going to multiply it by 17, and then I'm going to divide it by 18.5. Okay, so that's approximately 0.8876. Okay, so now I'm going to inverse sine that. All right, so inverse sine, second inverse sine. So it's much easier on a graphing calculator. You can just type in inverse sine, and remember I showed you where those are on your calculator. If you don't remember, you can Google it or something. Yay, Google. So 62.57-ish or 63-ish degrees, we'll go with that. Okay, so R is approximately 63 degrees. Okay, so that's example 1. Let's try example 2. Here we go. So here's what our triangle looks like. Call this A, B, and C. I like it when it's A, B, and C, because then we can just look right at our law of cosines, and it tells us word for word what we need to write. So the directions say find measure of angle C. So let's use this bottom law of cosine. So c squared equals a squared plus b squared minus 2ab times the cosine of c. Okay, so c, lowercase c is opposite angle c, so it's 21 squared equals 12 squared plus 18 squared minus 2 times 12 times 18 times cosine of c. So we can do all this math and this math. So here's what we get. We get 441 equals 468 minus 432 times the cosine of c. We're still trying to solve for C, so let's get rid of this 468. Okay, so we're left with negative 27 equals negative 432 times the cosine of C. Okay, so now divide by negative 432. Divide by negative 432. Okay, so that cancels. So our cosine of C equals 0.0625. So now I'm going to solve for C. So I'm going to apply the inverse cosine. And so my measure of angle C is approximately 86 degrees. All right, so there's a B to example 2. So let's write it right here. Example 2B. Here's what it says. In triangle DEF, which they don't show us, I like seeing it. D equals 60. C, or E, equals 48. And F equals 14. So we need to find the measure of angle D. So if you want, you can draw a little triangle just to kind of get your head around it. And let's see, the 14, it's not drawn very nicely. And then we can put the 48 here and the 60 here. So if 60 is D, then that means this is capital D. F is 14, so that means that's capital F, and this must be capital E. D squared equals E squared plus F squared minus 2EF times the cosine of D. Remember, these two guys correspond, and these are the leftovers. So let's do it. D squared. D is 60 squared. And E is 48, so 48 squared plus 14 squared minus 2 times 48 times 14 times the cosine of D. So you're going to clean all this up, and then you're going to divide by that, and here's what you end up with. It equals negative 0.8185 is approximately the cosine of D. So I'm going to apply the inverse cosine, and we get measure of angle D is approximately 145 degrees. Boom. Example 2 done. Thank you, law of cosines. That was nice. All right, the next part of this chapter, we're going to talk about Herons Formula. Herons Formula. Herons Formula. Let's see here. How to pronounce
Herons Formula.
That doesn't sound right. Ooh, Australian.
Herons Formula.
Here's Canada.
Herons Formula. Herons Formula.
Ooh, okay. So Herons Formula. Herons Formula. So Herons Formula is a formula that allows us to find the area of a triangle if only the three sides are given. So here's what Herons Formula is. Herons. A lot of people say herons. That's an incorrect pronunciation of Herons Formula. Durr. Silly. Herons Formula. A equals the square root of S times S minus A times S minus B. I totally have this memorized. I'm just looking over here because it's there's something going on that needs my attention. Times S minus C. Okay? So S is really just 1/2 times A plus B plus C. So here's what you're doing. You add all the sides together, divide it by 2, and then you throw that S into this formula. Okay? So we're going to do, using this formula, we're going to do example 3. So here's our triangle. pretty. 9, 11, and 18. So we're going to apply Herons formula. So S equals 9 plus 11 plus 18, all times 1/2, or all divided by 2. So that's 38 divided by 2, which is 19. Now we're going to find the area by taking the square root of 19 times 19 minus 9 times 19 minus 11 times 19 minus 18. Okay, it's getting nicer and nicer here with nice little numbers. So this is times 10 times 8 and times 1. So let's do that math. Area equals the square root of 1520 is 38.99-ish, or just approximately 39 square units. All right, so that was Herons formula. That's pretty nice. So in theory, I mean, the S's and A's and B's are all kind of weird, but you're basically adding up all the sides, dividing it by 2, and then you're taking that number and subtracting all the sides from that number, multiplying by that number, and then square rooting it. Okay, so I guess it is kind of confusing. But as long as you remember what S is, you'll be fine. S is kind of like a weird, messed up average of the sides, but it wouldn't be average because you divide by 3. I'm rambling. Last example is real life application. So that's it for lesson 77, the law of cosines. Hopefully it wasn't too overwhelming. It was a little long because we reviewed the law of sines, so this lesson kind of gives you both and when to use both. So hope that was helpful. See you in lesson 78.
Black man!